Hello, Year 8. Today we are going to be starting a new topic. The topic is probability. It is very likely you will have met this work in Year 7, so we are going to review some of the things that you should already know about the topic of probability before bringing in some new content. So I hope you've been able to print out the note sheet. If you've not been able to and you can't follow along with that in front of you, then you'll just need to write this into your book. Make sure you have the title, the objective, and your date also written down. So the first slide is just to go through some of the fundamental things that you should remember about probability. Probability is a mathematical measure of how likely something is of happening. The two ends of the spectrum, if we have something that can never happen, we sometimes refer to this using the word impossible. So an event that can never happen is often described as impossible. The opposite end of the spectrum, if an event will definitely occur, then that is called certain. And you might be familiar with other pieces of vocabulary such as likely, unlikely, equal chance, but just using words alone is not good enough to describe probability, so we use a number scale. And the probability number scale runs from 0 to 1, and you can express your probabilities using either fractions, decimals, or percentages. Now, obviously, if you're using percentages, that idea of the scale, yes, it would run from 0 to 100%. Now, there's two formulas that we're going to be using today, and it's very likely you'll have met the first formula last year. And this is why quite often when we deal with probabilities, we will use fractions because of this formula. The probability of an event is the number of ways that outcome can happen divided by all the different things that can possibly happen, and we'll see how we can use this in a moment. And then perhaps another formula that's new to you, but intuitively you would understand, and I think you would already be aware of this formula, is the probability of an event not happening. And that is 1 take away the probability of the event. So for example, if the probability of it raining tomorrow was 0.3, then the probability of it not raining would be what's left over, which would be 0.7, or 1 take away 0.3, which is 0.7. So let's start with a very, very simple example, but also if you're not familiar with the idea of probability notation from year 7, that's something that I really, really, really want you to have a go at today. So, start off with one of the most straightforward probability systems, which is a standard die. Now, I don't like using the word die, so I will be grammatically, is it grammatic? Well, from an English point of view, I will be wrong when I say a dice. It is a die, but I prefer to write a dice. So I want you to imagine that we have a standard dice, and a standard dice means it is fair. Every single outcome on that dice is equally likely, it has the same chance. And it says calculate the following probabilities, and it then says P and then in brackets 3. What that is your probability notation that I'm talking about. P standing for probability, and then what is written in brackets is what it is that you are finding the probability of. And obviously we as mathematicians don't want to write too much, so as long as we know that this is a standard die, that is pretty obvious. I mean probability of rolling a 3. If I wanted to be even more clear, I could perhaps write in the brackets rolling a 3. Now, let's think about the outcomes on a dice. There's 1, 2, 3, 4, 5, and 6. They are your total outcomes. There are 6 of them. The probability of rolling a 3 is just 1 out of those 6. And I'm going to write it as a fraction, 1/6. Funnily, if you wrote 1 out of 6 in words in an exam, that would get marked wrong. So make sure fractions, decimals, or percentages. Okay, it then says calculate the probability of an even number. Well, 2's even, 4's even, 6 is even. 3 of these outcomes out of the 6 are even, and we know from our last topic, 3/6 cancels to a half. So if in any questions today we have fractions and they simplify, we are going to get the practice. P prime, the probability of rolling a prime number. Well, which ones of these numbers from 1 to 6 are prime? Let's remember the definition of prime. A prime number has exactly 2 factors. So that is 2, 3, and 5. Very common misconception about the number 1. 1 is not prime. It only has 1 factor. So that was 3 out of 6 again, which is a half. I've then got P, N, an inequality symbol, and 2. Well, the N I'm just using to stand for number, but what inequality is this one? And this is where I start to think the crocodile eating the bigger number isn't helpful here. You need to learn the names. This one is less than, or with that extra line, equal to. So how many of the outcomes on a dice are less than or equal to 2? Well, 1 is, and 2 is. Everything else is too big. So it's 2/6, which is a third. And finally, the probability of not a 5. Well, there's 2 ways you can do this. You could count up all the ways that are not 5, and there's 5 of them. So it's going to be 5/6. Or you could do 1 minus the probability of a 5. So the probability of getting a 5 is 1/6. So 1 take away 1/6 is 5/6. Both ways work fine, but sometimes subtracting from 1 can be a little bit quicker. Let's look at another scenario. This time I've got some coloured counters in a bag. Now, these counters are different colours, they are different shapes, and they have different numbers written on them. Calculate the following probabilities. The probability of a green shape. Well, that's nice and straightforward. How many shapes are green? How many shapes do we have altogether? Can we find our fraction? So there are 2 green shapes out of 7. So the answer to that one is 2/7. The probability of not blue. Okay, so we can either count up the blue shapes and subtract that from 1, or we could count up the shapes that are not blue, and we can see there's 4/7. My next probability introduces a new word. It's the word or. And it says the probability that is blue or a triangle. So we can count up the shapes that are blue, and we can count up the shapes that are triangles. And I'm just going to put a little tick next to these. 1, 2, 3, 4, 5. Just sometimes have to be a little bit careful if you have something that fits both criteria that you don't count it twice. So that one's 5 out of 7. Okay, the next one says the probability that it is green and a triangle. Now this means it must do both at the same time, simultaneously. So it needs to be green and a triangle. And there's only one shape that satisfies those at the same time. That is 1/7. And finally, we've got the probability of not a prime number. Well, we've already talked about 1 not being prime, so it's all the ones that have a 1 on it, which is 3 out of 7. 3/7. So you'll see in this question I have used fractions, and fractions is my normal go-to for probabilities. But what I would say is if you have a question that is in fractions, work in fractions. If you have a question that is in decimals, work in decimals. If you have a question that is in percentages, it makes sense to work in percentages. Let's look at a final example. So example 3. In a football game, the probability that a team wins, loses or draws is shown in the table. And you can see the probability they win is 0.52, the probability they lose is 0.2, and the probability that they draw has been left blank. And it's asking, what is the probability they draw? Now, a team can only win, lose, or draw. So all of these must add up to 1. It must cover all of the eventualities in that probability system, so must add up to 1. Well, I already know that these add up to 0.72, 0.52 plus 0.2, 0.72. So what is left to add up to 1? Well, that would be 0.28. So I can say the probability they draw, so I'm using my probability notation, equals 0.28. What is the probability they do not lose? Well, you could add together win and draw. I'm going to do 1 minus the probability that they lose, which is 0.8. So there are some questions for you to try. We've got the usual 3 levels, and do remember to write down some probability notation, not just a final answer as a fraction, decimal or percentage. So it makes a little bit more sense. You're trying to explain what that answer is. Do remember 5 minutes before the end, you should be checking your answer with a different coloured pen, marking your work, adding corrections, and that should be done before you start taking photos of your work. As always, if you have any problems, do not hesitate to get in touch via the Ask the Teacher channel.